Hello everyone, and welcome back to my channel. This is Vishnu Manjipudi, and I am glad that you are all here. Today, we will be solving the first three problems of the 2020 United States National Chemistry Olympiad local section exam. So, without further ado, let's begin. So, let's go down to the first question. So we have that a 2.5 liter sample of butane gas, which is C4H10, measured at 22.0 degrees Celsius and 1.2 atmospheres of pressure, is combusted completely, and the carbon dioxide gas collected is at the same pressure and temperature. What volume of CO2 is produced? Now, this is just a simple ideal gas law problem. So, if you didn't know, the ideal gas law equation is PV equals nRT, where R is the ideal gas law constant, P is pressure, V is volume, N is equal to the number of moles, and T is the temperature. So, we're given that the initial volume is 2.5 liters. Okay, and we also have the molar mass, which is C4H10. We have the temperature, which is 22 degrees Celsius, and we always have to use Kelvin. So that's going to be equal to 295.15 Kelvin. Okay, and then 1.2 atmospheres of pressure. So we have 295.15 Kelvin and 1.20 atmospheres. And now it's combusted completely, and the carbon dioxide gas collected is at the same pressure and temperature. What volume is produced? Now, first, let's write out the equation, okay? So we know that pressure and volume stay constant, and we know that R is a constant. Actually, not P and V. P and T are constant, and R is constant. Thus, the only changing variables are V and N. Okay? So, we don't actually need to know the value of N. All we need to know is the amount N changes by to get the amount V changes by. And luckily for us, this is relatively easy to compute. If we just write down the combustion equation, you can just balance it yourself. We have C4H10. We need a 2 in front. Plus, we have 5O2 for the hydrogens, as well as 8O2 for the carbons. So that's 13O2. So O2 yields. And now what do we have on the other end? We have 8CO2. And then let's just add it down here. Plus 10H2O. And we can verify that the oxygens, carbons, and hydrogens are completely balanced. So, from this equation, we see that C4H10, or butane, and carbon dioxide are in a 1 to 4 molar ratio, i.e., the number of moles of carbon dioxide is equal to 4 times the number of moles of butane. And this is exactly what we needed, because we know that both of these two sides are equal, and that P, R, and T are constant. Thus, if N is multiplied by 4, then V must also be multiplied by 4. So, we never actually needed any of this information. All we need to know was the number of moles changed by. And since this is multiplied by 4, our answer is 2.5 liters times 4, or 10 liters. Now, let's move on to the second. So, how many hydrogen atoms are in 2.5 grams of pharmacolite, which is calcium, hydrogen, that's arsenic, 4 oxygens, dihydrogen, with a molar mass of 16. So this is not a hard problem. Since they are giving us the molar mass, all we need to do is find the ratio of hydrogen, and there are 5 hydrogen atoms in this molecule, 1 here and 4 here. So since we have 5, and that's out of a molar mass of 216, we have that the mass ratio is 5 over 216. So then we know that the mass of the hydrogen inside of the sample is 5 over 216 times 2.5 grams. And this is the number of grams. So we have the number of grams, but the question is asking us for the number of moles. Luckily, if we go up to the periodic table, we can see that hydrogen has a molar mass of 1.008 grams per mole. So we can multiply this by 1 over this conversion factor in order to get moles. So this is times 1 over 1.008 grams per mole, and mole per grams. Okay? And now, since we have the number of moles, to get the number of atoms, we just multiply by 6.022 times 10 to the 23rd. Now, if we just plug this into our calculator, we find that the answer turns out to be 3.457 times 10 to the 22nd. And 3.457 is the closest to 3.48 times 10 to the 22nd, and thus we are done. Because they use sig figs differently, so we just use the closest. Number 3. Methanol is produced industrially by catalytic hydrogenation of carbon monoxide, according to the following equation. So we have 1 mole of carbon dioxide plus 2 moles of hydrogen gas yields 1 mole of methanol. If the yield of the reaction is 40%, what a volume of CO measured at STP would be needed to produce 1.0 times 10 to the 6th kilograms of CH3OH, or methanol. Now, this is a complex problem that needs many parts to solve. So, we first need to find out the amount of carbon dioxide needed to produce methanol, that much methanol. So to do this, let's first calculate the mass of carbon dioxide. Now, we can check the periodic table once more to find that. If you're following along, you can just check the periodic table. The molar mass of carbon monoxide is equal to 28, approximately. And we have that hydrogen has a mass of 2, and there's a 2 times 2, and methanol has a mass of 32. So we know that for each 32 grams of methanol, we need 28 grams of carbon monoxide. But, however, the yield of reaction is actually 40%. So because of this, we need even more CO. So, since the yield of the reaction is 40%, we can just multiply this by 40%, or 2 over 5, to get that 28 28 gram of CO yields 64 fifths grams of methanol. Or in other words, if we just multiply by 5 and divide by 4, we have that 35 CO yields 16 of methanol, CH3OH. Now we can divide 1.0 times 10 to the 6th by the ratio, which is 35/16. To get that, the ratio is 35/16/35. To get that, we would need 10 to the 6th times 35 divided by 16 kilograms of carbon monoxide. So, now that we have this, we can just use the ideal gas law to find the volume. Now, for STP, we have that 1 mole of a gas equates in 22.4 liters. So, if we just convert these kilograms into moles, we can just multiply our answer by 22.4 to get the answer. So, we have 10 to the 6th times 35/16, right? But since we know that the molar mass is 28 grams per mole, we can actually multiply this by 1 gram over 1 mole over 28 grams, which is then multiplied by 1,000 grams in 1 kilogram. So then, after this, we get a grand total of 7.81 times 10 to the 7th moles. So now that we have the number of moles, we can just multiply this by the 22.4 liters per mole conversion at STP to get a total of, you have 7.81 times 10 to the 7th times 22.4, which gives us 1.75 times 10 to the 9th. So that's 1.75 times 10 to the 9th. And looking at all the choices, we see that the closest answer is 1.7 times 10 to the 9th liters, and we are done. Thank you so much for watching this video. It really means a lot. Please don't forget to like, share, and subscribe, as well as click the bell icon. As always, if you have any questions, comments, or concerns, please post them down below or email me at cmaspirations@gmail.com. Once again, this is Vishu Majipudi signing off. Bye, everyone.